Okay, let's jump right in. Welcome everybody to this week's clinic. And before I go on to talking about anything else, are there any questions about HDF5, the use of HDF, and
there were some improvements to the documentational website, so it points to the date when it was last updated, which is great, and it has working horizontal bar. But now bar on the left that supposed to use the list of functions disappeared. So I work in progress, but really it's much nicer.
Okay, we like to hear that. Lori, do you want to say anything about documentation?
Well, I'll be making a post on the forum shortly, just to announce that we've made that change to latest. There are a couple of pull requests that were kind of last minute yesterday, I think even. So, and I also think Amazon caching may be an issue for us right now. I haven't heard back from Les, but I think different people, because Alexander's having issues that we're not having. Are you in Illinois right now, Elena?
Yes, and I see the latest documentation from today, but I don't see if any changes were done to the bar. On the left, there is no bar when you come to the reference manual page. But when I click on the, say, H5P, I will not see functions on the left side as it was before.
Okay, we'll take a look.
Okay, any other questions, thoughts, comments? No? Then, okay, I'll jump right in, and I call it better tools for HDF5. And yeah, documentation is related to that. It's, of course, not a coincidence that if you post a survey near documentation, that perhaps the topmost issue people have is related to documentation. But then, of course, if you think about it, it's not that people like to read our documentation like they would read a novel or something like that. It's more likely to put them to sleep or something else or run away. But they want to use it to make more effective use of HDF5 and perhaps create better tools. And I think that's very important. And so that's where I'm coming from today. And let me give you some context first. And when I say here, no pun intended, what I mean is, of course, we will talk about LLMs and how important context is for LLMs. But before I go to LLMs, let's talk about some tools that I like that sort of were exemplary at the time in their heyday. But then, is there something we can learn for today's tools for HDF5? First up, my example would be IBM's Data Explorer, or later they renamed it. They called it Open Data Explorer. And if you click there, you can read up all about it. Interesting enough, ChatGPT knows about it, and the answer is perfectly in order. It also gives you a nice sort of rundown of the key features of DX, and it even includes screenshots and things like that. But that's why I'm bringing it up here, one of the lesser known features of DX is actually, and it was one of my favorites at the time, it included something called the data prompter. And interesting enough, not at IBM, but Georgia Tech hosts an HTML version of the old DX documentation. And if you go there, you can read all about the data prompter. But long story short, the idea was really, you had some data and you were not a data explorer, a DX expert, but you wanted to see something on the screen. You wanted to put together a visualization, or start somewhere and then evolve it, make it prettier and more meaningful and all the rest of it, more informative. But the way this worked in DX, or with the data prompter in particular, was there was basically a sequence of dialog boxes that it would take you through. And then at the end, boom, you had a visualization window and you saw something, and depending on how complex your data was and how you answered the questions and so forth, you might have said, nah, that's not what I had in mind. Or you said, wow, that's exactly what I need, and you've gotten on with your life. But anyway, I think it was a great idea, and it was pretty successful at the time for people who knew that it was out there. Next one up, HDF View. Interestingly enough, ChatGPT knows about HDF View and hits all the high marks, and tells you something about key features and technical details, meaning how it's implemented and all the rest of it, and who uses it. And you could take that in a similar stride. It's sort of, trying to reduce complexity through visual metaphors. So who knows, one day, right now we are very much focused on large language models and language in the sense of written language or oral language or something like that. But then, hey, there are visual languages as well, and maybe not too long, we will see visual language models. And I think with HDF View, the best HDF View is actually yet to come, and more about that in a moment. And if you are interested, John Reedy is organizing a roundtable around HDF graphical user interface tools, sort of the state of affairs and the contenders, the candidates, what one does better than the others, and what as a community we might do together. So I included the link here for HUG 25 in case you haven't registered. Go there, register, and attend as much as you can, but in particular, if you care about tools, John's roundtable. And then I sort of was only on the periphery of this, but I remember in the HDF group, we did something called the HDF product designer, and I actually found a few slides. So if you search for product designer, you come up with these slides. And interesting enough, these slides are pretty old. I think product designer was maybe in the late 2010s, so I would think it predates, or it's well within the horizon of the training data for ChatGPT. But anyway, ChatGPT claims that there's no official role or tool titled HDF product designer in the HDF5 ecosystem. So it thinks, depending on the context, it could mean different things. But interestingly enough, to its credit, it picks up on the context that I had in mind, which is that, if you want to think about it as a tool that would let you design, if you wish, data products, the profile, the sort of the layout as groups and data sets decorated with attributes and so forth. That's certainly the context that I had in mind. And what product designer was actually designed to do was to also create, in addition to helping you design a data product, to then actually create an API. And I believe at the time the APIs were C, Fortran, Python, MATLAB, I think those were the 4, if I'm not mistaken. Actually, if I went back to the slides, I think the slides might have the details. But then, of course, what happened with the product designer, this was not LLM-based code generation and things like that. This was pretty manual and laborious and all the rest of it. So I think it was a good idea. It was just a few years early. And but okay, we move on from that. And I think, yeah, perhaps there was never a better time for creating useful and interesting tools than today. And that's where a paper that just came out 2 weeks ago comes in. And that paper has a very interesting title. That's also why it caught my attention. But before we go there, let's talk about README files. And again, holding up the conversation with ChatGPT, I think there's nothing surprising here that README files in this day and age still have a place and purpose, whether it's for a software project or a data set or whatever resource you might want to share. You want to give someone an idea about, it's kind of the label on the tin to describe what to expect, what to find inside, and perhaps how to get started. And now if you take that idea and think about development and tools development, you might say, wait a minute, if in this day and age, LLMs are pretty successful at generating code, so mimic developer-like skills and capabilities, you might say, okay, a developer needs good documentation and intelligence and things like that to be productive as a developer and create tools, make effective use of something. But what if a computer, in double quotes, developer were supposed to complete a task like that? What would be the counterpart? Would that entity, that tool, also need some kind of documentation? And that's where this paper comes in. And it's actually a very simple but brilliant idea. Is these people basically said, okay, if you look out there in the LLM world, there are all these new protocols and standards for tools. There's the MCP protocol, for example, the model context protocol. Then earlier, OpenAI introduced the tools API. And so just as ways of enriching the context in which LLMs would generate code or utilize tools, invoke workflows and things like that. And you might say, okay, that's great, but could it be even simpler? And the answer is yes, in a sense, and that this is what this paper is about. Let me actually quickly open it here. It's we don't have time to go through it. So it's here on archive, and if I briefly open the PDF, it talks about this concept of a readme.llm rather than a readme.md, and the, in double quotes, intended audience for this readme.llm are LLMs. And they use they do two case studies here, and that's actually how I found it. There is a first case study here about this tool called Supervision, but more interestingly, there is the second case study here about Digital RF. And Digital RF is actually a library that implements conversion from WAV, which are some kind of audio files, to HDF5. And then you could ask, well, sure, a developer can sort of sit down and read the digital RF documentation, and at the end of the day, write a tool or create a workflow that does the conversion from WAV files to HDF5. But the clue or the interesting experiment that the authors here did is to say, well, what if we had a README file of the right kind with the digital RF library, and then point an LLM at it and say, make it part of a prompt for an LLM, and then let it create the code for that conversion, in the hope that the code generated would be more accurate, not have syntax errors or hallucinations and things like that, and also without having to write an MCP server or something like that. And if you are interested, so the experiment went well, I can tell you that much, but if you are interested in the details, I recommend you check out that paper. Now, going back to us, you might say, and the HDF5 library is just one example, but you could think then about the high-level libraries or other customized libraries that build on top of HDF5. What would a README.LLM for the HDF5 library look like? And the structure that the authors of this paper propose looks as follows. So initially, you have kind of a set of rules, like call that invariants or constraints or something like that, where you can say something about the etiquette. So for example, in the case of the HDF5 library, because you don't want to introduce resource leaks and things like that, that if you use the C API, you want matching open and close calls and things like that, and you want to check error codes and all the rest of it. And then there would be a general description of what the library does for you. And then it would be what I would call a cookbook style set of recipes, where each individual recipe is framed as an example. And an example is basically, here's the task that I would like to complete, or here's the cake that I would like to make, or something else. And then you provide a code snippet. And in this case, using Python, but it could be in C or in other languages. And this is basically what you do is you provide a set of good examples that reflect, if you wish, best practices to approach this. So you could have, for example, a variant on this. Let's take this task here, for example, read an existing HDF5 data set. If you had a task, read data sets from a small HDF5 file. Of course, then the question would be, well, what do you mean by small, or what is small? But putting that to one side, you might say, well, if it's small, it's probably worth using something like the core VFD, the in-memory driver, and just wholesale load the entire thing. And if you are looking at the majority of those databases, well, those will all be memory accesses, and there's no reason to go back to disk and so forth. So there could be variants of these recipes for different situations. And then similarly here, adding an attribute and iterating over things. So the key points here are really, you want to give the LLM, you in this context, you want sort of clear operational guidelines. You want to set the terminology that people will use to express what they would like to achieve. And in the case of HDF, at that sort of vanilla HDF level, that would be data sets, groups, and attributes. But then in a context like HDF EOS or something like that, that vocabulary could clearly be richer, where you would talk about grids and swaths and so forth, which then would translate into combinations of these primitives. And then, yeah, provide recipes that cater to the needs of your users, but also that represent sort of good practice for that particular library or module or whatever it is. And that's really all there is to it. And if you think about it, it's yeah, that's isn't that how we as children or in everyday life learn new things? We don't, rarely do we go to first principles and learn from the ground up what a tree is. It's just, yeah, where our parents and grandparents and siblings sort of reinforce what is a tree or what isn't a tree, and pretty quickly we get it. And that's pretty much what this is all about. Now, what does that mean, coming back to our original theme, for tools in HDF5? Well, the truth is, of course, that what I would call out-of-the-box experience for HDF5 is pretty dismal. And there's plenty of good work going on, no question about it. But there are just too many bits and pieces that really don't seem to cohere very well. And then, of course, plenty of pieces that really show signs of neglect and so forth. And yeah, we got to do a lot better than that. And so if, in my opinion, HDF5 is really the most versatile container for sharing scientific and engineering data, why couldn't we do something similar on the tool side, in the sense that, okay, on the data side, we, in a way, give people a toolkit so that they can actually make that container their own, tailor it to their needs, customize it, and so forth. So why couldn't we do something similar with tools? And if you think about it, that was definitely, although within the technical limitations of the time, and then after a while not so well executed, that was one of the ideas behind HDF View, where people said, well, yeah, there is this plugin interface, and whenever people do conventions and so forth, they can just add their own plugins and so forth, and then it's going to give them a richer visual experience and so forth. So the idea was definitely there, but yeah, it sooner or later fell by the wayside for a variety of reasons. And so with this, whether it's MCP servers or tools or this readme.llm, I think we definitely need that talent in the community. So we need real people to work with. But I think we have so much more on the technology side that we can rely on nowadays, that creating tools, so looking back at the examples that we had here, OpenDX and Product Designer, if we want to do them today, yeah, we have sort of almost dreamlike capabilities that weren't available at the time. And I think, and I hope some of this will be part of the discussion at John's roundtable. But yeah, I think we will very soon, I hope, see a renewed effort to drastically improve the quality of HDF5 tools and really create a exemplary, what I would call out-of-the-box experience. And if you ask me, well, what do you mean by out-of-the-box experience? Well, in the simplest case, just getting data into an HDF5 file without a lot of ceremony. And so, for example, in a GUI tool, that you can just drag and drop a CSV file and it just happens. no questions asked. That's kind of the minimum. And it should be much better than that. But even that minimum, we seem to have trouble at this point. And it's not, you don't need fancy technology for that. I mean, that was possible a long time before the arrival of LLMs and so forth. Anyway, I'm going to answer any questions there might be in a moment, but then there is already, I'm already thinking ahead. So a lot of this thinking about LLM related themes comes up in our IO Walk project. If you're interested, I put a link here. And one of the things that keeps coming up on the science side, so we have material science partners here from the University of Utah, and it comes up on the system side, there's always this question about generalization. Generalization, for example, in the sense that, well, yeah, if you do an old-fashioned search, you search for something very specific and you try to be as specific as you can in the hope that then you will not be presented with 10,000 relevant links, but rather maybe a handful or no more than a handful. That is kind of a maybe not the right way of looking at it, because yeah, as a scientist, the chances that the precise answer to the questions, as you put it very precisely, can be just found through a search, that's kind of a fanciful idea. And so what you really want is this generalize it. So as when you, for example, in the context of LLMs, you generate a prompt, that generalization has to happen somewhere. You are interested in a certain class of materials, for example. Don't ask specifically for this particular material at this temperature, yada, yada, yada. There's an encyclopedia or database somewhere for that, if that's what you're looking for. But if you are looking for something like a science assistant, you are looking for ideas, what and how to conduct certain experiments, you need this generalization somehow built in. And in my thinking, I think, yeah, LLMs plus graphs and some knowledge graphs in particular, that might just be the best technology that we have at the moment to really make a lot of progress. And that's where I'm going to leave it. And there's something in the chat, NTD. Oh, sorry. Any questions? No? Okay. Then, well, thank you all for coming. And yeah, I'm going to post the link. This is in the HDF Clinic GitHub repo. I'll post the link there. And yeah, thanks for coming. See you another time.
Thank you. A lot of things to think about.
Good. See you.
Thank you.
Bye.
Bye-bye.
Thanks.